is by a model that extends RDF a little bit with some constructs that we just call nodes and edges. And nodes and edges are just containers for RDF triples. But each of these nodes or edges, or what we call a hyperedge, has its own unique URI attached to it. And it's essentially it's a container for multiple triples. So in the pharmaceutical data, for example, you could have one node representing disease, and then every triple that you know about that disease goes into that node. This is just a way to group your information together so that your queries are ultimately more efficient. And by having this hyperedge construct there, this allows you to do what we call reification, where you can have a statement about a statement. So if you have node, edge, node, an edge pointing to that edge, what you're doing is you're making some data point to a relationship. So you can say, where does this relationship come from? Let's say this was Pfizer acquires Wyatt or something. That hyperedge could point to the article where that statement came from. So you can manage your provenance, which is very important in the semantic world. Where does your data come from? Is your data trustable? And so forth. So how we actually construct these semantic networks is by a series of interconnections or relationships. For example, we have here a drug which treats a disease. Very simple node, edge, node type of scenario. We could also have statements that are a little bit more complicated, where you could have, Abbott competes with Wyeth. These are two companies with a competition relationship between them in the context of a market. In this case, the market of rheumatoid arthritis. This could be something that's directly stated, or it could be inferred. For example, you could have Abbott creates a product, that product treats a disease. Wyeth creates a product, that product treats a disease, and thus infer that because they're treating the same disease, thus they are in competition. So that's really the distinction between something that's directly stated or coming from an inference. And we also incorporate more of collaborative or social types of relationships. So person, colleague of person, this is basically friend of type relationship. And so all of all of social networking all boils down to an ontology of one relationship, friend of. So we incorporate these types of relationships like member of a team, expert in a particular subject, and we put that all into one bucket so that we can query that across lots of information. From an unstructured point of view, and I note there was a couple questions about unstructured data, this is how we handle a fairly complicated statement. So this would be coming from a document like a research article where we're talking about the suppression of a protein being involved in a particular biological process. We would parse that sentence, come up with a parse tree that's over there on the side, and then this is how it actually gets represented into our graph database. So these are all just RDF triples with a fairly complicated parse tree attached to it. But this becomes our queryable source of information. As we parse information, boil it down into RDF triples, as we have sort of chunked them up into nodes and edges, and then go from there. But once we've done that and layered these different types of relationships together, you get this, we call an innovation network, where you've got all this information tied and hooked together that you can then query in interesting ways, and you can calculate relevancy across this information. So that's one of the key aspects of other types of semantic technology. You can have a big repository of knowledge, but what knowledge is important? So by looking at what you care about, you can essentially surface knowledge by the connections. People are represented in this network, so if this node represents you, the things that you care about it are a cluster around you, and then the pathways between you and the information dictate what you find interesting and important, and what information should get surfaced to you. So an innovation network is really a combination of the knowledge that you're extracting from all your different data sources, and a collaborative network on top of that. Within your enterprise organization, there are probably many people that are known to be experts at certain things. So it would make sense to leverage that and have the information that accrues around a particular expert to be where you look for first when you actually are looking for an answer to a question, looking for some sort of business insight. So if you have an expert across a particular type of acquisition category or segment of the market, the first place to look could be the information that's around your in-house expert, so you can tap your experts without bugging them. So with this platform, basically we call either a semantics as a service or platform as a service with applications in life science, business intelligence, and R&D. Social networking, we have a customer that's using it in a social networking context where there's a normal social network, but attached to the different users is information that they find highly relevant. And by having a separate unit that can produce semantic information, it's very easy to hook in to their existing infrastructure and apply just a little semantic context where needed. Another customer of ours is more of a media search for the real-time web that uses our search infrastructure to identify the most interesting bits of media out on the internet. And something new that we're just starting to work on is tracking of brands, where lots of brand information gets funneled down with semantics into a way that's visible.